Hello everyone, glad to be here at stackconf 2021, and today I'd like to talk to you about monitoring microservices the right way. A word about myself: my name is Dotan Horovits. I'm a developer advocate at logs.io. I've been around as a developer, as a solutions architect, a product manager. I'm an advocate of open source software, open standards, open communities in general, and the CNCF, Cloud Native Computing Foundation in particular. I co-organize a local CNCF chapter in Tel Aviv, Cloud Native Tel Aviv, so if you're around, do join one of our monthly meetups. I also run a podcast, Open Observability Talks, about open source and DevOps and observability, so if you're podcast fans, do check it out in your favorite app. And in general, you can find me anywhere at Horovits. My company, logs.io, provides a SaaS platform for cloud-native observability, which essentially means that you can just send your logs, your metrics, your traces to one centralized managed place for indexing and storage and visualization. And the beauty is that it's all based on popular open source that you probably use, such as Elasticsearch, Kibana, Prometheus, Jaeger, and so on. If you're interested, check out the URL here at the bottom, and especially for the participants of stackconf 2021, worth your while. And with that, let's check out how to monitor our systems, modern microservices systems. But before that, let's recap on how we used to monitor our systems actually not so long ago. So the popular combination for monitoring was StatsD and Graphite, both open source tools. Our applications were relatively simple, largely based on homegrown code that pushed metrics to StatsD over UDP. StatsD server aggregated the metrics and sent them over TCP to Graphite backend for storing and visualization. You can see here how a visualization of Graphite metrics would look like on the screen, and also the metrics, how metrics look like. That's the common, famous hierarchy dot notation of Graphite, representing essentially how our application is deployed in the environment. So in this example here, we have production, inside it the web server, in it the HTML service, and in it the respective metrics, request total count, it could be error total count, or any other. The main takeaways from the way we used to monitor are first that metric collection was done in push mode. So each and every piece of our application knew that StatsD server and was configured to push to that server. Secondly, the hierarchy notation, and in general, the way that we interact with the metrics and query the metrics is based on the hierarchy notation. Each dimension of our metric is a part of a hierarchy, and also that a lot of our applications was based on homegrown code, which meant that it was easier to instrument and control the way that it exposed metrics. But then came microservices and cloud-native architectures, and things started getting messy. So let's look at the changes in the architecture and how it impacted the monitoring, and then also we'll see the solutions and what you need to do in order to meet these challenges. The first change was the shift to microservices. And first, the shift brought about a surge in the number of discrete entities that we need to monitor. If you look about on Amazon or Netflix, on Uber or others, they talk about thousands, if not more, proprietary microservices. But even the most modest application today, what used to be one monolith, is today dozens or more microservices. Each microservice is a cluster of multiple instances. Each service potentially running its own programming language and database, each one independently deployed and scaled and upgraded. And these systems are highly dynamic, volatile, ephemeral, things spinning up, tearing down, scaling in and out. So from monitoring perspective, first we need to monitor many entities, much more than we used to, but also very diverse and very dynamic in nature, which means high volume of metrics with many dimensions, high cardinality metrics, as it's called. So the shift to microservices disrupted the monitoring in one way, and then came about cloud native architecture and Kubernetes and added more complication, because now I need to monitor applications spanning multiple containers and pods and namespaces, deployment versions, potentially over fleets of clusters. And this introduced many additional dimensions for my metrics. Now I can ask about my microservice performance per pod, per node, per version, etc. In addition, the Docker and Kubernetes, or all the container framework, are critical systems that need to be monitored as well. For example, here on the screen you can see examples of Kubernetes control plane services, whether on the node level, such as a kubelet and a kproxy, or on the master node, such as the API, the etcd, the manager, and so on. Each and every one of these control plane services by Kubernetes, I need to make sure that they're up and running and performing and responding and so on. So microservices and cloud native architectures. And the last piece that I would like to talk about is the third parties. And again, we did use third parties even before. Yeah, it's not something new, but I think with the microservice architectures in the cloud native realm, it got a significant boost. And the fact being that today's systems use many libraries and tools and frameworks for building software, including the web servers and the NoSQL databases and the SQL database and the API gateway and the message broker and the queue and so on. For example, here on the screen you can see a typical data processing pipeline, and just see how many open source frameworks or cloud services are potentially involved in just running through that data processing pipeline. And that's just the data processing out of the entire system. So we need to monitor these third-party tools, and this tech stack keeps updating at an increasing pace. The chase after the latest tech stack is becoming crazy. So monitoring systems today need to provide integration with a large and very dynamic ecosystem of third-party platforms to provide complete observability. So just to recap on the challenges before we move on to the solutions, first is microservices that brought about many entities that we need to monitor, high volume of metrics with many dimensions, high cardinality metrics. Then cloud native introduced more layers, more virtualization, and also adding additional dimensions, per pod, per node, per version, etc. And also new critical systems to monitor. The Docker, container runtime, and Kubernetes are also in need of monitoring. And thirdly, the large and dynamic ecosystem of third-party platforms we use in our system, whether open source or cloud services, that we need to monitor as well. And new challenges obviously call for new capabilities. And in the rest of the talk today, I'd like to devote to the requirements that you'd be looking for when designing your monitoring system to make sure that you can meet these challenges. So the first requirement is flexible querying over high cardinality. We saw before the hierarchy notation, the dot notation, and it worked well for static machine-centric metrics. But it turns out to be too strict and too cumbersome even to express the dynamic services metrics with high cardinality that we saw before for today's modern systems. If we go back to the example that I showed before, of the web server. So we had a web server in our environment, and so we saw the request total for that web server. But today, in the microservice architecture, that would probably be a microservice that is clustered and spans across multiple nodes and multiple pods. So this query may be a query I may want to query about the metric on a specific pod, or on all the pods on a specific node, or maybe on across the entire service spanning multiple nodes. So each one of these is a different metric in the hierarchy notation, because in the hierarchy notation, introducing a new dimension effectively creates a new metric, because we have a dot something, it's just a new string. The entire concatenation defines the metric. So a new dimension, which is a new piece of the chain of the concatenation, is a new metric in effect, which makes it quite difficult to expose highly dimensional data. It also is difficult to do query-based aggregation. So if I want to do a group by something that I haven't planned on before and pre-aggregated, it may be very tricky in the hierarchy notation. If you think, for example, if you have multiple servers and you want to group by error code, how do you do that in the hierarchy model? It's quite complex. So all of these drove the shift to a more flexible querying, the need for flexible querying, and that means from a hierarchy model to the labeling model. A labeling model is essentially a key value pair pairs that we can attach to the metric. I have the metric name, and then I have a key value pair of the different dimensions. The keys are the different dimensions. And then it was not, by the way, nicely introduced by the PromQL query language that was brought about by Prometheus open source project. But since then, it's been adopted by many others. And that's definitely the going forward path. So if I look at the same example we've looked at before, in the labeling model, I would look now at an HTTP request total metric, and then I can state which labels I'm interested in. So if I want to query on a specific pod, then I would state, for example, server equals pod 7. Or if I want across the entire service, I would just state service equals Nginx. And that's obviously a very small example. In real life web applications where we have the web server software, Nginx and Apache, and you have multiple environments like production and staging and so on, and you have the HTTP methods, post and get, and the HTTP response code, and the error code, and the multiple endpoints and so on. Any ad hoc query that I would like to ask my system, like what is the total number of requests per web server in pod in production, or what's the number of HTTP errors using Nginx server for a specific endpoint in staging, or what's the slowest post requests segmented by endpoint URL. All of these become very easy to query ad hoc based on the labeling model. So flexible querying and the labeling model is definitely a requirement that you would like in your monitoring system. Next up is metric scraping and auto-discovery. We saw in StatsD days that the application pushed metrics to the StatsD server. But systems today have many microservices and third-party frameworks, as we've seen before. How would you configure each microservice and third party to push metrics to your monitoring backend? It can be quite complex. Would it be great if our monitoring service can discover the services itself and pull the metrics from them? And that's exactly what Prometheus open source project introduced with the Autodiscovery and the metric scraping. Prometheus, by the way, is an open source under the CNCF. It's in fact the second project to have graduated from the CNCF after Kubernetes itself. And Prometheus can essentially find or discover these components, these services, these targets in Prometheus terms within the system. And we've seen in microservices it could be many and very diverse, and also third parties and so on. And then it can pull metrics off of these targets, or scrape, in Prometheus terms, scrape metrics off of these targets, instead of them having to push it to Prometheus. We can do that thanks to open metrics, which is an open standard for transmitting metrics, or an exposition format, a way to expose metrics in a standard way, that has become quite standard across the industry. It's standard under the CNCF sandbox project. It's based on Prometheus format, so it's pretty established and mature. It's these days being proposed as a standard under the IETF, a real formal standard. But the most important thing here is that many tools and frameworks today expose out of the box metrics using this format. So, Kafka and RabbitMQ and Mongo and MySQL and Elasticsearch, Apache, Nginx, Jenkins, Jira, GitHub, cloud services, AWS ECS and Azure Health and others. So whatever third parties you use in your system architecture, you're more than likely to find that they already have built-in exposition of expose out of the box these in this format their metrics. So and that's really essential, because the key here, as we've seen with the challenges before, that this large ecosystem is key when dealing in such with such diverse and dynamic system as we today face. Now, Prometheus being together with Kubernetes under the CNCF, then not surprisingly that Prometheus has a native integration with Kubernetes, both for the Autodiscovery, the service Autodiscovery, and for the scraping. It can integrate with the Kubernetes API, with kube state metrics, and so on. It can also integrate with the broader cloud native ecosystem. For example, it can integrate with console to get the service discovery and the configuration, and similar. So and also service discovery services from cloud services. So it's very much plug and play in many of your ecosystem. And the third requirement that you would like to in your system, in your monitoring system, is scalability. We've seen that systems emit these days massive amounts of high cardinality metrics, which means high volume of time series data. And Prometheus, with all its virtues that we've seen here, is by design a single node installation. So it can't scale horizontally. One option for scaling out Prometheus horizontally is to compose Prometheus instances into a federated architecture, shard your metrics, and so on. There are lots of information on the web about that. But that can become quite complicated to manage. Another option is to write to a long-term storage backend. Prometheus has built-in capability to remote write to a backend store. And there are other quite a few time series databases that can serve as long-term storage for Prometheus, offering compatibility with Prometheus APIs, of course, and with the PromQL query language. So you can query across the Prometheus instances and the long-term storage uniformly. Many of these are open source solutions, such as the M3 that we use, and InfluxDB and Thanos and Cortex. By the way, both Thanos and Cortex are projects under the CNCF, and they have a lot of interaction between them, and also, of course, proprietary services such as logs.io. Now, it's important to mention that not all the long-term storage solutions use remote write from Prometheus. Thanos, for instance, offers a pull mode from Prometheus. But the important thing is that Prometheus still serves as the scraping agent. So we still leverage the seamless integration and the ecosystem and the scraping capabilities. And the question being whether Prometheus then remote writes to the long-term storage, or whether the long-term storage pulls off of the Prometheus instance. So let's summarize what we've seen here. Monitoring microservices and cloud-native systems introduces challenges with high volume of metrics, with a large diversity, with the many dimensions, the high cardinality of the metrics, highly distributed with many third-party tools and frameworks involved. And in order to monitor these and meet these challenges, we need first flexible querying. And the key here, as we've seen, is labeling model. So having key value pairs attached to each metric. Each label is a dimension, and then we can query high cardinality metrics with many dimensions very easily, but just specifying the relevant labels we're interested in. Secondly, we would be looking for efficient metric scraping with Autodiscovery, so that our monitoring system can automatically discover the services, the components of our system, and then pull or scrape the metrics off of them in a uniform manner. And thirdly, scalability, so that we can actually handle large volumes of metrics, store them efficiently, and also over long periods of time, so that I can actually query things that are metrics months away or even a year or two away with just as ease as I would do in the past weeks. And as an open source advocate, I'm more than happy to say that open source is taking a lead here. We've seen Prometheus as a leading tool for scraping and discovering and scraping metrics. We talked about open metrics as a standard, an open source standard for exposing metrics across the ecosystem. We talked about time series databases that can provide long-term storage to scale Prometheus and to now allow querying over long periods of time. And we mentioned also the seamless integration with Kubernetes and the cloud-native ecosystem. If you'd like to read more about this topic, then I wrote an article about that, so do check it out. I'll post it here on the chat as well. There's also a great episode of Open Observability Talks that specifies very well how to actually deploy and monitor real systems these days. And of course, the relevant communities, the Prometheus community, the Open Metrics community, and others, Open Telemetry, by the way, and other interesting discussions, because things move so fast that oftentimes the latest and greatest you'll just find on the community discussion. So do check them out. And of course, feel free to reach out to me with any questions or comment. I'd be more than happy to touch base and discuss further. So you can find me at Horovits. I've been Dotan Horovits, and thank you very much for listening.